So really quickly, I'm going to show you guys another subset of constraints known as the tracking constraints. These tracking constraints have a variety of different uses, but mostly it's just a point at constraint. So you're able to get an object to rotate so that one of its sides is pointing at the object of interest. So let's go ahead and take a look at this bone here. I'm going to add a bone constraint to this bone, and let's go into the bone constraints tab, and we're going to add any of these tracking things here. Of course, we have a lot of different options here, and we're going to explore each and every single one of them. The one I like to use the most is damped track, and I'm just going to eyedropper tool this guy. And as you can see here, it's very intuitive. You just sort of make sure that this object continually points at the origin point of this object. So that's pretty cool. Let's try throwing on a different one here. We have clamp 2 inverse kinematics, these, and spline IK, which of course stands for spline inverse kinematics. These are going to require a little bit, they're not exactly the same. These work a little bit differently. Now, inverse kinematics is going to have its own video. It's very complex. That goes along with spline IK. Track 2, let's go ahead and try track 2 and see if that does anything cool. Looks like we have something very similar here. Not really a huge discernible difference, except that you have a little bit more control over how this is going to deform. So you can actually use local space, and it deforms very differently. So if you have a little bit more of an advanced need for tracking, for example, you can't actually have these two axes the same. But yeah, if you have a little bit more of an advanced need somewhere in there that you can manipulate these settings a little bit more to what you want, track 2 is the one to use. Now we also have stretch 2, which is actually pretty interesting. Of course, this should be pretty intuitive. It just sort of stretches to the object and points to it, which is great. That's also very helpful. So then we have locked track, which is pretty interesting, where you basically, it tracks exactly the same way. It points to the object, but if you notice, it actually locks a single axis here. So you can actually just sort of lock whatever axis you want, but it'll track along the other two. And you can set which axis is actually pointing to it, and you can't actually have these two the same because then you're tracking and then locking the same axis. So if we do that, you'll notice that the this is actually tracking along the x-axis of the bone, as this x arrow should be the one that's pointing towards it at all times, as you can see here. But it is locking the y-axis. You can also lock the z-axis so that it's technically using that, but only moving along there. So that's a pretty interesting way to do it. That's basically a track 2 and then a limit rotation. So that's a very helpful track as well. So that's the basics to tracking. Very, very simple. We're going to go into inverse kinematics and stuff like that later on. I do want to talk about this clamp 2 constraint. This clamp 2 constraint actually only works on curves. So it only clamps to curves. So it won't actually clamp to this cube here. As you can see here, it says fail to set value. So if you want to use the clamp 2, it basically makes it so that it follows the curve. So if we just add a Bezier curve right there with Shift A and then eyedropper tool that, you'll notice that it just sort of follows it now. It just kind of snaps to it, clamps to it, and then just works like so. So yeah, that is the clamp 2 constraint. Pretty simple and intuitive. But yeah, that's the basics for the tracking constraints in Blender. We'll go more into the inverse kinematic side of things in the future videos.